let's go to Lico 792, number of matching subsequences. So give us a string S and ask how many the counts of words in this kind of words which is subsequence of S. So we know for each word we can do check if the word is a subsequence of S, right? So we just do two pointers, okay? Um, um, then we iterate each word, check whether it is subsequence of that. Doing like this, there is some problem for this, is that the the um, the time complexity will be because for every word, for example, if the length is n, right? If we check if it is a subsequence of s, we just we do two pointers that will be, for example, this is n multiplied by n, right? L, and if there are m words, that time complexity will be n multiplied by length multiplied by m. So for this kind of question, actually, we can do using something called a next array. So what does the next array mean? Is that for in the string S, we find what is the next position include the current index. That is from current index. What is the character from A, B, C to Z the indexes of the first occurrences from this index. So, for example, if we have A, B, A, C, D, right? So at index 0, we'll say this A, or we are the next is 0, right? And what about B? B is 1, right? And C is 3, D is 4, right? And until Z is something. And at the um, index 1, what do we have? A. The next one will be index 2, right? And this one will be 1. And C will be index 3 and 4. And we do a pre-processing of string about its next index array. Then for every word, we just check the next index array to see whether it is a subsequence. So how can we check whether this word is the subsequence of S? Is that for every word, right? We check, for example, this word is apple. We try to see does A, what's the next? It is 0, right? And then going from this, from 1, right? Do we have P? Because we already have this kind of next array. So what we check is just this kind of length. So it will be just length multiplied by m words, right? Doing like a next array, it is an O n operation. But the good thing is that instead of the multiple by n and L and M, right? We separate the two processes. One process is to create a next array. So that is the ON operation. The second process is to check the word. That is OLM operation, right? So let's write code for this. We're going to have char array equals s to char array. And we're going to have a this one as array of length, and we're going to have int next array equals new int in multiply by 26, right? We can put this one as n plus 1, right? So that's the we can do even we don't need to worry about the corner cases. That is the last character. So what we do is that for int I equals n minus 1, I greater equal to 0 and minus, right? So we'll say for int j equals 0, j smaller than 26, j plus plus. So for every character, we know the next I j will be next I plus 1 j, right? And we have one more n plus 1, right? Because for this one, we don't need to worry about its next one. Actually, doing like this, we need to do some initializations. Otherwise, the next, because the default value is 0, that is not correct, right? So we can do this into row in next arrays fill next row. We can set this one as -1, or you can also set as n or those kind of value, right? But which is out of the range. And also we'll have next um, I. So this character is um, array I. So the index is this one -a equals I, right? So doing like this, we compose the next array. Um, so we can also use this next array to check if a word is a subsequences of S, right? So now every word has only a relationship with this next array. We don't need to worry about this kind of S, right? So we can write a private boolean is subsequence, and we're going to have int next array and the int word, right? So we'll have int index equals -1 for every character in word to each array. What we do is that index equals next say this will be index, right? So that is index +1 and c minus a, right? So if index equals -1, right, return false. And if we go through all of the word, all of the character in the word, right, we return true. So then we just count, right? So we have int result equals 0 for every word, right? For every string word in words. So if is subsequence next and the word, we're going to have result plus plus in the end return result. Right? Doing like this, it will be this is n, right? So this will be n operation to create the next array. And then this is for some m word and length, right? So that will be n plus m multiplied by length, right? And the space will be 26 n, right? And Python code should be very similar. Let's also write Python code for this. We're going to create a next array equals -1 multiplied by 26 for underscore in range. Let's get its length, right? N equals the length of S range m plus 1. Then what we do is that for I in range and -1, -1, right? So we're going to, for j in range 26, we're going to have next I j equals the next I plus 1 j, right? And also for this special character, we need to update that is I, that is already this s I minus already uh, a, right, equals I. So result equals to 0 for word in words. If is subsequence, for example, next word, then we're going to have result plus equal to result plus equal to 1. And in the end, just return result. And let's define is subsequence. And we are going to have next, which is an list int, right? And also word is a string, and it returns Boolean. Cool. So what we do is that index equals -1, right? And for say in word, index equals next index +1. And what is this index order say? Hey, and so if this kind of index equals -1, right, we return false. If we go through the whole word, uh, we all find the next index. It's not -1, it's a return true.